Hi everybody, today I'm going to talk about FRINX Machine, our latest product that tackles workflow, inventory and network control. And here's what's going on. With FRINX Machine, we are combining a number of different functions into one solution stack. The basis is built by FRINX OpenDaylight together with the Uniconfig framework, and that allows you to translate between OpenConfig and vendor proprietary CLI and netconf dialects. It also gives you the capability to do network-wide transactions. It allows you to pull operational data in a common format from different devices and generally allows you to manage heterogeneous networks. On top of that, we've added workflow and inventory capabilities. For the workflow, we've picked Netflix Conductor. It's a beautiful microservice orchestration solution that's vastly scalable, that's battle-proven, that's in use by Netflix today, and we really like the approach. For the inventory system, we've picked Elasticsearch. It's a great tool. Everybody loves to work with it. It has a great front end with Kibana, and it's also well understood. So it perfectly does what we needed to do. The next step was to put this together in a container-based solution that makes it extremely simple to set up. We need 3 commands. One is git clone our repository. The second one is install to create all the containers and infrastructure. And the third one is startup. The whole thing runs in a couple of minutes and it just works beautifully. You can install it in a minimal version, not needing more than about 4 gig RAM on your local PC, or it can run in a really high-end scalable machine in the cloud as well. In the following demo, we show you 3 workflows. One is we create a device in the database in Elasticsearch. The second workflow is we mount that device in OpenDaylight. And the third workflow is we pull inventory data from that device and store it back again in Elasticsearch. This is the UI of Conductor. We've changed that a little bit to fit our needs. And what we do here is we select a workflow, the one that writes a device into the database, and we fill in basic data like node ID, host information, iOS version information. And finally, we execute that workflow. What you see here is the graphical representation of a workflow. We have created a bunch of workflows for you, but of course, this is completely customizable and you can create your own workflows and they would then be displayed here as well. Once a workflow is executed, you can see the exact execution status, the state it's in, the time it has taken for every step, and you can see the input and the output variables of each step in the workflow. Now, here we have succeeded. We see the device in Elasticsearch through the Kibana interface. So first workflow was successful. The next workflow takes that information out of the inventory database and mounts the device in OpenDaylight. Here we see a 2-step workflow. There's some types that we can choose to further select which devices we want to mount. We're going to execute that workflow, and now we're going to see the current execution status. We got the first step, and after a little time, it'll go to the next step and completion. In this example, we see a fork and a join. That means we can, at runtime, create multiple workflows that are sub-workflows that are executed at the same time. So if we have more devices that we want to mount at the same time, that can be created with that with the same workflow. It will execute in parallel and come back when all the devices are mounted. In the final workflow, we go to the device and extract inventory information via CLI command, via an unstructured data. We convert that unstructured data in OpenConfig format and then store it in our inventory database for further retrieval. Here you can see the join and the fork of the dynamic creation of the sub-workflows. This allows us to collect a number of devices, dozens or hundreds, and execute commands concurrently on all these devices. So for read commands, we can go to 100 devices and read that information from them and then process it and convert it into OpenConfig. Here we see the Kibana interface again, and when we refresh it, we see that there is a new data structure there for the platform information. That's what we've retrieved from the device and converted into OpenConfig. Now we are looking at this with in a more detailed view, and we see all the different line card, OS versions, hardware information stored here in Elasticsearch, ready for retrieval. So we hope this was useful for you. We had a lot of fun in putting this together. We'd love to hear from you. Go to GitHub and check us out, install it. We'd love to hear your feedback. Take care. Bye.